Life on Earth is in a constant state of flux. Over immense periods, species change and adapt. Evolution is driven by survival of the fittest. Imagine beetles with color variations. If predators prefer lighter beetles, darker ones survive. They pass their traits to offspring. Over generations, the population becomes darker. This is natural selection. In a world increasingly affected by climate change, the ability to adapt swiftly is crucial. Species with short lifespans have a distinct advantage. They can respond to environmental pressures more rapidly. Consider bacteria, with a lifespan of mere hours. They can undergo thousands of generations quickly. This allows for swift adaptation to changing conditions. The natural world is replete with examples of rapid adaptation driven by short lifespans. Fruit flies, with a lifespan of just a few weeks, have been observed evolving resistance to pesticides in a matter of years. Mosquitoes, notorious for their ability to transmit diseases, have developed resistance to insecticides at an alarming rate, posing challenges for disease control efforts. Even larger organisms with relatively short lifespans exhibit this phenomenon. House mice, for instance, have developed resistance to multiple rodenticides in a matter of decades. This rapid adaptation highlights the evolutionary arms race between humans and pests, a race that often favors the species with faster generational turnover. Beyond lifespan. Other factors in the adaptation equation. While lifespan is a major factor influencing adaptation speed, it is not the sole determinant. Other factors come into play, such as population size, genetic diversity, and the intensity of environmental pressure. A large, genetically diverse population is more likely to harbor beneficial mutations that can fuel adaptation. Likewise, intense environmental pressure, such as rapid climate change, can accelerate the pace of evolution. The interplay of these factors creates a complex tapestry of evolutionary responses. Understanding these dynamics is crucial for predicting how species will cope with the challenges of a changing world. A tale of two timelines. Short versus long life in a changing world. The contrast between species with short and long lifespans highlights the different paces of adaptation. While short-lived species can rapidly evolve in response to environmental shifts, long-lived species face a greater challenge. Their slower generational turnover limits their ability to adapt quickly. Consider planktonic algae, microscopic organisms that form the base of many aquatic food webs. Their short lifespans and rapid reproduction rates allow them to adapt quickly to changes in water temperature, salinity, and nutrient availability. In contrast, long-lived species like whales or elephants, with lifespans spanning decades or even centuries, face a greater risk from rapid environmental change. Their adaptation relies on existing genetic variation and the slow accumulation of beneficial mutations over many generations. The human factor. Our place in a changing world. Human activities are driving unprecedented environmental change. Fossil fuels, deforestation, and industrial agriculture are altering the planet's climate. This rapid change challenges many species, including our own. We are not exempt from evolution. Our adaptation depends on understanding these forces, addressing root causes, and our capacity for innovation. The future hinges on navigating these challenges with wisdom. Please like and share this video. Thanks for watching. Until next time, stay safe and live your best life.